This video will show you how to do RRAM4, which means the right-hand rectangular approximation method for the area under the curve of y equals x squared plus 3 from x equals 1 to x equals 5. So let's take a look. The first thing we want to do is put in the diagram, which would be the rectangles attached to the curve. If you notice the way the rectangles are drawn here, the right-hand side of each rectangle is touching the curve, which is going to create an overestimate in this particular case. The rectangles are labeled by k values, k equals 1, 2, 3, and 4. Let's find the width of each rectangle by subtracting the highest x value in the interval minus the lowest x value in the interval. So the base of the rectangle, which is also the width, which is also called delta x, would be given by 5 minus 1 over 4, or 1. So the width of each rectangle in this particular case is 1. So now we want to make a chart to help us convert from x values into k values when we go to find the area of the rectangles. So we start by writing the k values, 1, 2, and 3. And remember, that just means for the first rectangle, that's when k equals 1. When k equals 2, we're talking about the second rectangle, and k equals 3 is the third rectangle. In this problem, the first rectangle, noted by k equals 1, has the right-hand side of the rectangle touching the curve. So we want to plug in a value of x equals 2 into the equation x squared plus 3 to find the height of the first rectangle. The second rectangle is found by plugging in x equals 3 into the equation x squared plus 3, and that again would be the height of the second rectangle. The height of the third rectangle would be 4, and lastly the height of the last rectangle would be 5. So we can now fill in the chart for the x values, 2, 3, and 4 for the first rectangle, second rectangle, and third rectangle accordingly. Now that's going to allow us to make an equation to convert from x to k values. The equation here, it looks like anytime you have a k value, you increase it by 1 to get the x value. So we can write the equation x equals k plus 1. We are now ready to sum up the areas of the four rectangles, denoted by k equals 1 to 4, area of the kth rectangle, meaning area of 1 plus area of 2 plus area of 3 plus area of 4. The area of each rectangle is base times height, so instead of area, we can replace it with base times height. We've already found right over here the base of each rectangle is 1, and we know that the height of each rectangle can be found by plugging in the equation x squared plus 3. But for evaluation purposes, we don't really want to use x's in this equation. We really need to convert into k's. So we go back here to our equation, x equals k plus 1, and we're going to plug in anywhere we see an x. So we're going to get k plus 1 quantity squared. We still have the 3, so we'll add the 3 to that as well. Simplifying by expanding out the k plus 1 will give us k squared plus 2k plus 1 plus the 3 that's still at the end. Further simplifying gives us k squared plus 2k plus 4, and at this point we are ready to break apart the expression into each individual sigma. So we have sigma k squared, sigma k, but we can factor the 2 out in front of that, and the sigma 4, which is sigma constant. Applying each formula, k squared, n plus 1, 2n plus 1 divided by 6. The 2 times k, 2 times n plus 1 divided by 2. And lastly, n times the constant, 4 times 4. Evaluate each expression, 30 plus 20 plus 16, and we get the value of 66. So 66 would be an overestimate, but we're going with that as the approximate area under the curve by approximating with 4 rectangles on the curve x squared